handshakes. Or hand hugs. Hand hugs. Those are good.
Okay, here we go. 9.1, it's called polar coordinates. I think I might have put a D at the end, but it's supposed to be polar coordinates. Okay, this whole chapter is all about polar coordinates. New graphs you've never seen before. Where you find this in the real world is air traffic controllers. They make a lot of money, by the way, but they have one of the highest stress jobs in the country. Radar, oceanographers. This is what type of a graph we are going to study for this whole chapter. Kind of looks like a bullseye, doesn't it? You've never done bullseyes. You've never graphed on a bullseye. And we're going to make another one here. Something new you've never seen before. Not hard at all today. Okay, so when you plotted points back in the old days in Algebra 2, and I'm just going to show you, and I asked you to put 3, 4 down, you could tell me that 3, 4 is here, couldn't you? Right? Okay, this was the X and this was the Y, this is the X and this is the Y, correct? Okay, now it's going to change on us, and this is what you need to know. You are going to still study ordered pairs and ordered pairs, but it's not an X and a Y. It's an R, which stands for the radius of each of the circles are up there, correct? And theta, which would stand for the angle it makes. So, for this one, this is 0 degrees, this is 90, this is 180, this is 270, and all the way back around is 360. There are 2 ways to plot points on this one, and there's 2 ways to plot points on that one. To plot points, I can have a positive R and a positive theta, or I can have a positive R and a negative theta. This is the positive R, and if I go in this direction, it's a positive angle. And if I go down, it's a negative angle, right? Just like you've known before, right? If you go up, it's positive. If you go down, it's negative. Okay, you've never seen the right side graph now. You've always seen it as 0, 90, 180, 270, and all the way back around is 360, correct? Now, this graph this is 0 degrees. Down here is 90 degrees. Over here is 180 degrees. Up here is 270 degrees. And all the way back around is 360 degrees. Something you've never seen before. This is going to be a negative R, because you're going to come to the left to find what kind of radius you have. This one, you're going to go to the right to figure out what type of radius you have. Then you can have a positive theta, or you can have a negative R and a negative theta. If you look at all 4 of them, they're all different. A positive R, positive theta, positive R, negative theta, negative R, positive theta, negative R, negative theta. And I'll just show you how to graph one of each. Good, to show you how to graph it. So, if I gave you 3, 30 degrees. If I gave you 3, negative 180. Over here, I'm going to give you negative 3, 45 degrees. And this one needs to be both negative. So let's do negative 3, negative 120 degrees. And I'm just going to plot points with this. So, 3 stands for how far out the radius you need to go. Isn't this the first little circle? Isn't that a radius of 1? Isn't this the second little circle, a radius of 2? So don't I have to go out to this one, which is the 3rd radius? And you have to go 30 degrees. So go out 30, or not go out 30, go out 3 and go up 30, up About 30, does that look about 30 degrees? Does that, if you took a protractor, does that look like 3 comma 30 degrees? And that's it, that's the first point. If I asked you to graph 3 comma negative 180, I'm still going to go out here 3, but instead of going this direction, I need to go down, right? So 3, negative 180 is about right here. That's about 3 comma negative 180. On this graph, when you have negative r, you can do exactly the same thing, except if it's a negative r, instead of going to the right, you need to go to the left. I need to go to the left 3, 1, 2, 3. Here's my third circle. I need to have a positive 45. Well, 0 to 90, going down is positive on this chart. So a negative 345, here's the negative 3. Halfway in between this one is a positive 45. And then the last one, same thing. It's a negative 3, so I go out negative 3, but it's a negative. Negative means you go up. And if you go up, isn't this a negative 90, right? And almost past the negative 90, do we have to go about right here? Is about a negative 3, negative 120. And all that was kind of an introduction. I'll do the 3 parts, and we're pretty much done with notes today. Okay, ready to go. This is a positive R. This is the negative R. Let's see what we do here. Ready to go on our parts? Okay. Oh, don't need that. Okay, big bullseye. Look at that. Part 1, Draftees. That's all we're asking you to do. Today, when you get, I think I'm giving you like 8 of these to graph. Only make 1 bullseye and put all the dots on the same one. Don't keep making bullseyes, right? I found this on a smartboard. So, a negative 4, 0 degrees is what they want you to graph. So, do you see this is the first radius? It goes blue, red on my graph. Everybody see that? So, if I want to go out a negative 4, I'm going to go to the left 4. 1, 2, 3, 4 right here. And do I have to go anywhere? No, this is a negative 4, comma 0. And then on your homework, label this problem number 1. I graph problem number 1. And then graph number 2 on the same graph. Why make another graph? Where is a negative 1, negative pi over 3? Where's a negative 1, negative pi over 3? A negative 1 is the little blue circle, correct? And if I have to go, isn't this really a negative 60? So is a negative 1 is going down negative or going up negative? Up is negative. So, I don't even know how to... Okay, I get this. So, this is 90, correct? This, I think you're going to get graphs like this for the rest of this chapter. This is 90, isn't this red one right here 45? So, if this is 45, all of these blues must be counting by 15. Everybody got that? So, what are we doing now? Negative 1, negative 60. Negative 1, negative 60. Right here, right here. To make it that big enough, it could be any degrees. 2. Problem number 2. The next one now, do you see your radius has changed to a positive 2? So are we going to go to the right first and not to the left? We're going to go a positive 2, which makes this red circle. And we need to go a negative 40. What's a positive 2 and a negative 40? We're going to go a positive 2, which is right here. Are we going to go down or are we going to go up? We're going to go down. Oh, it's like I look at it too close and I'm kind of... Yeah, and it's driving me nuts. I shouldn't have picked this one. 2. So about right here then, right? Yeah. 3. Good. Anybody want any more for part 1? Everybody got it? I only did a negative, positive, negative, negative, positive, negative. I guess I could have gave you a positive, but I think you got it, correct? Okay, next part. Second part is kind of fun. Given the point, name it 4 different ways. I gotta give you the point. Where are we? Right here. I give you paper later on in this chapter. You don't have to keep making these, but I think you can make. So 1, 2, 3, right here. They're going to give you this point, and they're going to label this point 3, 70 degrees. This point is 3, 70 degrees. They want you to find 4 different ways to write that same point. So they want positive, 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 negative, negative, positive, negative, negative. So here we go. You'll have to do this on the test too. So you need 2 positive r's and 2 negative r's. So far so good, right? 2 positive r's, 2 negative r's. Okay, if I want another positive angle, can I just add 360 to 70 to be in the exact same spot? So, what did I just say? 360, 430. So 3, 430 would put you on the same spot. Okay, now I need a positive 3, but a negative number, right? So I'm going to go in this direction. It's going to be a negative 290. 3, a negative 290. Then I need to start here at the negative 3 marker, correct? Let's do the positive one first. If I do positive, don't I have to go down? So if I go a negative 3, 90, 180, add 180 to 70 is 250, positive 250. Did I do that? Yeah, I did that right. A negative 3, a positive 250. And then I need to do the negative, and this is negative. How much past? Isn't this 90, and then isn't this only about 20 degrees? So isn't it going to be a negative 110? Final answer.
How does actually and going on the right? Like, you're going out to, like, out negative 3.
Okay, I'm going out to a negative 3. And since this is negative, when you go down, it's positive.
Yeah.
And when you go up, it's negative. And if I'm cruising and I start at negative 3,
You like the negative 1 time.
this is a negative 90.
Yep.
This is a negative 180. Negative 180 and another negative 70 will give you that. Oh, I meant positive. Ugh. Yes. This is positive. Everybody got it? Okay, moving on from part 2. Last part. Part 3. Last section. Part 3, graph. Review the x equals 2. How do you regraph theta equals 6? How do we graph r equals a negative 3? So I just want to review algebra. Algebra. If I asked you to graph x equals 2, does most of you know, back in the olden days, isn't this what you did? X needs to be 2, correct? You guys remember doing this way back in algebra 1? X needs to be 2. Can't y be anything it wants to be? Can't y be 0, 1, and 2? 2, 0, 2, 1, 2, 2. What happens when you connect the dots? What does it make? A vertical line, right? What happens when you have a y? Doesn't it make a horizontal line, right? Same concept when you do polar graphs. You're going to have an r and you're going to have a theta because that's how ordered pairs work, just like x's and y's work. What the heck? I missed part of it. Theta is supposed to be 60 degrees. Can't be just 6. It needs to be an angle, right? Theta is 60 degrees. Can it change? Or does it have to be 60 degrees? Can r be anything it wants to be? R can be 1, r can be 2, r can be 3. What type of a graph are you going to make if theta is 60 degrees? Well, let's make a quick little, this is good enough, right? What's 1, 60 look like? 1, 60, you go out 1 and you go up 60, you put your first dot, it's right there. Like that. What's 2, 60, you go out 2 and up 60. What's 3, 60, go out 3 and up 60. What happens when you connect the dots? Doesn't it make a line? When theta is 60, r can be anything it wants to be. And it would make a line. Could I keep going on both directions? What happens when r is a negative 3? R has to be a negative 3. Well, what can theta be? Anything you want. Let's make it 30. Let's make it 180. Let's make it 270. Whatever you want it to be. What happens when you just have an r equals a negative 3? That's good enough. I'll do it in black. What's a negative 330? Negative 3 goes in this direction. 1, 2, 3. Negative 330 is about right there. What's a negative 3 180? Negative 3, positive 180 is over here. A negative 3 270 is right here. So what happens if I did all the angles? What would it make? A circle. Because you could put it here, here, or in algebra, you made vertical lines and horizontal lines, correct? In polars, you make diagonal lines and circles, correct? Any questions on today's assignment? You have, don't I have it down? I have it right here. Page 558. 16 through 40. Oh, it's not going to take long. Because remember, you're going to make one bullseye and put all the points on here. You've never done this before. The more you grasp them, the better you're going to get. So, page 558, 16 through 40.
Oh, 40.
Page 558, 16 through 40.